Welcome to our capstone. Our presentation focuses on salamander diversity and endemism in Appalachia and the impacts of climate change on habitat range and distribution. The southern Appalachian highlands is a region of maximum diversity for salamanders of the family Plethodontidae, a species whose ecology is largely driven by climate variables such as temperature and precipitation. As viable habitat may continue to decrease for a variety of salamander species in Appalachia, not only will the biodiversity of the region suffer, but entire ecosystem dynamics may experience pronounced consequences. Our project focuses on endemic salamander species in Appalachia and how climate change variables, particularly changes in annual precipitation and temperature, are expected to impact population distribution. Due to the current pandemic situation, we had to alter our original plans for this project. Our adjusted capstone will be a creative project in the form of a story map and website, providing an outline of the unique ecology of salamanders in Appalachia, supplemented with visual representation in the form of maps displaying how climate change is affecting habitat viability and subsequently the range of certain endemic species. Additionally, a video presenting a few common species of salamander is an anticipated product of our project as a result of our own fieldwork. The objective of this project is to provide a popularized summary of salamander ecology in Appalachia and past research supporting the impacts of climate change on certain endemic species. By doing so, it is our hope to create an alternative to traditional scientific publications on the subject and promote the conservation of Appalachia's unique salamanders.
To find some local species in the Appalachian region, our field team headed out to Strawberry Hill Foundation in Fairfield, PA. We took 2 trips, one day trip and one night trip, both within 24 hours after rainfall. To document this, the field team shot and captured many photos and videos, which were then edited using Adobe Lightroom and Adobe Premiere Pro. To the right top is a blue spotted salamander. This was captured during our night trip by our field team. And to our right below is an eastern newt, which was also captured by our field team during our day trip. In our map section, we focused on precipitation and temperature for the endemic species range in southern Appalachia, West Virginia, and Virginia. The precipitation and temperature maps that were used were obtained from the global climate database, WorldClim. Once the maps were found on the database, they were then added to ArcGIS.
Originating in the southern Appalachian region about 60 to 70 million years ago, Plethodontidae has since evolved into the largest family of salamanders in the world. And while many species have expanded their ranges beyond their ancestral home in the southern Appalachians, 21 remain endemic to the Appalachian region and can be found nowhere else in the world, including the Yancey salamander, which is pictured here. Southern Appalachia features montane forests with high rates of precipitation and a stable, temperate climate, ideal habitat for members of Plethodontidae. These species rely on moist conditions given their method of respiration. Appalachian endemics such as Weller's salamander exchange oxygen and carbon dioxide through their skin rather than through lungs and are perfectly adapted to the forested highlands. This map outlines the distributions of the 10 endemic species our project focused on. There's a clear geographic distinction, as we can see the majority of species have ranges exclusive to the southern Appalachians, while a few outliers remain further north. Of the 7 distributions shown on this map, the Yancey salamanders, shown in gray, is especially drawn out. Its range stretches over 3 states and is the largest of the 10 species mapped, yet is dwarfed in comparison to salamander species found more widely, as we'll see in a few moments. The Pigeon Mountain salamander is highlighted in pink and shows the disparity in ranges of these mapped endemic species. The Pigeon Mountain salamander occurs on one lone summit in the Cumberland Plateau. Notice the majority of species occurring along the border of Tennessee and North Carolina. This can be attributed to the high elevation running in congruence with this border. The geography of this region resulted in salamander species becoming restricted to certain areas and thus forming new, distinct populations in these isolated pockets. Examples of which are the southern gray-cheeked, red-cheeked, and red-legged salamander, 3 species whose distributions are shown on this map to be adjacent and are all closely related and are known to hybridize. Here's a photo of a redback salamander captured by our field team at Strawberry Hill Nature Preserve. Redback salamanders are also the family Plethodontidae, but can be found throughout much of the eastern United States and into Canada. This species has been known to be aggressively competitive with other salamander species, including the endemic Shenandoah salamander and peaks of otter salamander, two species with incredibly small ranges. Given the already limited distribution of these endemic species, coupled with their vulnerable conservation status, the competitive exclusion of the two from optimal forested habitat, which the redback salamander prefers, is a cause for concern for their future conservation. However, the future conservation of Plethodontidae and endemic salamanders of Appalachia can be most notably associated with the future outlook of global climate change. We can see that a large portion of Plethodontidae species already feature an unfavorable conservation status, while 40% are in danger of extinction.
By looking through a series of peer-reviewed sources on the Plethodontid family, it can be seen that their ecology is strongly governed by temperature and precipitation. Because they are amphibians, salamanders have very poor skin that allows water and gases to travel in and out of their bodies. With less rain and increase in temperatures, salamanders can dry out, being detrimental to their species. Using data from the World Climate Association, we made maps for both temperature and precipitation. This precipitation map here, it can be seen that a majority of our species reside along the deeper blue regions, or regions with greater precipitation. By taking a closer look at the southern species, such as the southern Appalachian salamander, the red-legged salamander, southern gray-cheeked salamander, and the red-cheeked salamander, it can be seen that a majority of their distribution reside along the same patch and the same patch of precipitation. The same patterns can be seen in the temperature maps as well. Salamanders, who typically inhabit leaf litter, streams, and subterranean tunnels, all of which remain relatively cool year-round, can all be seen in this map to like the yellow or the moderately cool regions, with the exception of the cheap mountain salamander, who likes an even cooler environment pictured by the light blue. Again, take a closer look at these southern species, specifically the ones we looked at earlier for precipitation. All four of these species again have the same temperature needs, with a cool environment around 60 degrees Fahrenheit. These four species are located in the Great Smoky Mountains. The Great Smoky Mountains are a mountain range rising along the Tennessee to North Carolina border in the southeastern part of the United States, forming a part of the Blue Ridge Province. As we can see in this elevation graph, looking at the sections of the Appalachian Mountains with significant mountain ranges, it can be seen that the Great Smoky Mountains have significantly more mountains above 3,000 feet. With the region south of Appalachia unsuitable due to higher temperatures and less rain, they would be forced to move north if climate change affects their boundaries. However, just as the south, the farther the species travels north due to climate change, the amount of suitable habitat for these species will decrease. Accelerated climate change is proven to be a threat to these long-term existence of many montane species, as they often have narrow thermal and precipitation tolerances, which get too cold or get less precipitation as they move north.
From the research we conducted by creating a collation of published peer-reviewed sources, we were able to conclude that climate change poses a serious threat to the endemic salamander species of Appalachia. Changing temperatures and precipitation patterns disrupt their habitats as well as their ability to thrive. Based on current trends, salamander populations will continue to decline. One of the main goals of our project is to bring attention to this issue and to raise awareness around conservation methods. The first proposed conservation method is through the political system. Increased policy that is more stringent in addressing CO2 carbon emissions will help in reducing global climate change. Additionally, policy that focuses specifically on protecting the habitat of the salamander populations will benefit them greatly. We also propose that citizens should be encouraged to take individual actions to reduce their carbon emissions, be sure to leave no trace when hiking through these areas, and make more mindful and earth-conscious decisions in their daily lives. Finally, one of the primary conservation methods of our project is a focus on awareness. Drawing attention to this problem will help to inspire change. Here I've included some data about the Appalachian Trail, which is obviously only a portion of the entire Appalachian region, but within the trail itself, it encompasses 6 national parks, 8 national forests, 2 national wildlife refuges, 67 state-owned land areas, which include game lands, forests, or parks, and more than a dozen local municipal watershed properties. By caring for and protecting national parks and public lands, the salamander population will benefit as a byproduct. The final deliverable of our project is a website that makes learning about this issue accessible to the public. The setup of our website is an interactive storyboard which includes the GIS maps and graphs created by our group, as well as the photography and videography we produced, the findings of our research, our conservation proposal, and a way to contact our team with any questions or comments. Thank you so much for your time and attention. We'd like to acknowledge Professor Andy Wilson for his support through every element of this project and for making this process easier during a challenging situation. We'd also like to acknowledge Professor Jeffrey Williams in the Cinema and Media Department for loaning us equipment and helping us with the editing of our photos. And finally, thank you so much to all the professors and students in the entire ES department for a great 4 years.